They say history is written by the survivors. But what if the greatest story ever told lies frozen beneath miles of ice, waiting in perfect silence at the bottom of the world? Tonight, we journey to the most remote and forbidden continent on Earth, where ancient maps reveal impossible coastlines, where Einstein himself endorsed theories that could rewrite everything we know about human civilization, and where the legendary lost city of Atlantis might not have sunk beneath ocean waves, but instead lies preserved in crystalline perfection beneath the Antarctic ice sheet. This is a story that begins with a Turkish admiral's map from 1513, a document so extraordinary that it sparked decades of controversy and scientific investigation. It's a story that weaves through the correspondence between Albert Einstein and a maverick geologist, through the discovery of tropical rainforests buried beneath polar ice, and into the realm where myth meets science in ways that challenge our most fundamental assumptions about the past. If these whispers from the edges of accepted knowledge draw you in, if you find yourself curious about the mysteries that linger just beyond the reach of conventional wisdom, then settle into this journey with us. Let me know in the comments where you're listening from tonight and what time it is in your corner of the world. I love seeing our community of seekers gather from across the globe, united by curiosity and the gentle pull of the unknown. The idea that Atlantis might rest beneath Antarctic ice isn't merely the stuff of wild speculation. It's a theory that has attracted some of the most brilliant minds in history, and it's built upon a foundation of scientific evidence that grows more intriguing with each passing year. To understand how we arrived at this extraordinary possibility, we must first journey back to 1929, when a forgotten map was discovered in an old palace in Istanbul, a map that would challenge everything historians thought they knew about ancient geographical knowledge. The Piri Reis map, drawn on gazelle skin by Turkish Admiral Hagi Ahmed Muhyiddin Piri in 1513, shows something that should have been impossible. Not only does it depict the coastline of South America with startling accuracy, but it appears to show Antarctica nearly 3 centuries before the continent was officially discovered. Even more remarkably, the Antarctic coastline shown on the map matches not the ice-covered continent we know today, but the actual bedrock beneath the ice, as if the mapmaker had access to knowledge of Antarctica as it existed before its current ice cap formed thousands of years ago. When this map came to light, it created a sensation in academic circles. How could a 16th-century cartographer possess such precise knowledge of a continent that wouldn't be discovered until 1820? Admiral Piri Reis himself provided some clues, stating that he had compiled his map from 20 different sources, including charts drawn by Christopher Columbus and maps dating back to the time of Alexander the Great. But even these ancient sources couldn't explain the Antarctic mystery. The puzzle deepened when scholars realized that the Piri Reis map appeared to use the Mercator projection, a sophisticated cartographic technique that European mapmakers wouldn't develop until the late 16th century. The precision of the coastal outlines, the accurate placement of islands, and the mathematical sophistication of the projection suggested access to advanced geographical knowledge that conventional history insisted simply didn't exist in 1513. Enter Charles Hapgood, a professor of history at Keene State College in New Hampshire, who in the 1950s began developing one of the most controversial geological theories of the 20th century. Hapgood proposed that the Earth's outer crust could shift rapidly over the inner layers, causing entire continents to change their positions relative to the poles in relatively short periods of time. This theory, which he called Earth crustal displacement, suggested that of as stable what we think continental positions are actually quite fluid over geological time. What made Hapgood's theory particularly compelling was the support it received from perhaps the most famous scientist of the era, Albert Einstein, the architect of relativity theory, and one of the most respected minds in physics, not only endorsed Hapgood's work, but wrote the foreword to his 1953 book, Earth's Shifting Crust. In this foreword, Einstein wrote, "I frequently receive communications from people who wish to consult me concerning their unpublished ideas. It goes without saying that these ideas are very seldom possessed of scientific validity. The very first communication, however, that I received from Mr. Hapgood electrified me. Einstein's endorsement wasn't given lightly. The great physicist was intrigued by Hapgood's mathematical calculations, showing how massive ice buildups at the poles could create imbalances that might cause the Earth's crust to slip over the underlying mantle. As Einstein explained in the foreword, in a polar region, there is continual deposition of ice, which is not symmetrically distributed about the pole. The Earth's rotation acts on these unsymmetrically deposited masses and produces centrifugal momentum that is transmitted to the rigid crust of the Earth. According to Hapgood's theory, such a crustal displacement occurred around 12,000 years ago at the end of the last ice age. Before this event, Antarctica occupied a position much farther north, enjoying a temperate climate that could have supported advanced human civilization. When the crust shifted, Antarctica was transported to its current polar position, and what had once been a thriving continent became locked beneath miles of ice. This timing is particularly significant because it aligns with one of history's most enduring mysteries, Plato's account of Atlantis. The ancient Greek philosopher described Atlantis as a powerful island civilization that existed 9,000 years before his own time, placing its destruction around 9600 BCE. Hapgood's proposed date for the crustal displacement falls remarkably close to this timeline, suggesting that what Plato described as the sinking of Atlantis beneath the waves might actually have been the freezing of Atlantis beneath polar ice. But could Antarctica really have supported advanced human civilization just 12,000 years ago? Recent scientific discoveries suggest that not only is this possible, but that Antarctica has been capable of supporting complex life much more recently than previously thought. In 2020, researchers drilling into sediment cores near the Pine Island and Thwaites glaciers made an extraordinary discovery that rewrote our understanding of Antarctic climate history. Buried 90 million years in the past, they found evidence of a lush, temperate rainforest that had thrived near the South Pole. The preservation was so remarkable that individual cell structures were still visible in the fossilized remains. Even more surprising were the climatic conditions this ancient forest had enjoyed. Temperature reconstructions showed that the annual mean air temperature was around 12 degrees Celsius, roughly 2 degrees warmer than modern-day Germany. Summer temperatures reached a comfortable 66 degrees Fahrenheit, with rainfall similar to contemporary Wales. This discovery shattered the assumption that Antarctica has always been the frozen wasteland we know today. Professor Tina van de Vliert, one of the study's co-authors, remarked, "The preservation of this 90-million-year-old forest is exceptional, but even more surprising is the world it reveals. Even during months of darkness, swampy temperate rainforests were able to grow close to the South Pole, revealing an even warmer climate than we expected. But we don't need to reach back 90 million years to find evidence of a habitable Antarctica. During the Eocene epoch, approximately 55 to 48 million years ago, East Antarctica supported near-tropical ecosystems. Data shows that winter temperatures reached more than 10 degrees Celsius, creating essentially frost-free conditions despite the polar darkness. The landscape was characterized by highly diverse forests that included palms and other warm climate vegetation, painting a picture of Antarctica as a verdant, habitable continent. Even more recently, during the Middle Miocene period between 20 and 15 million years ago, Antarctica experienced what scientists call the Antarctic greening. Large quantities of pollen and algae found in sediment cores indicate that the margins of Antarctica were less like a polar desert and more like present-day Iceland. As researcher Sophie Warney observed, the southward movement of rain bands associated with a warmer climate made Antarctica's coastal regions surprisingly hospitable. These discoveries reveal that Antarctica's transformation into a frozen continent is neither permanent nor inevitable. The continent has oscillated between ice-covered and temperate states throughout its geological history, raising the tantalizing possibility that it could have been habitable during the time frame when human civilization was emerging elsewhere in the world. The mechanism by which such dramatic climate changes could occur is found in the dynamics of crustal displacement itself. Hapgood claimed that toward the end of the last ice age, the extensive mass of glacial ice covering northern continents created an imbalance that caused the lithosphere to slip over the underlying asthenosphere. This movement, occurring over perhaps several centuries, transported Antarctica from its previous position in the middle latitudes to its current polar location, while simultaneously rotating other continents to new positions. The speed of this transformation would have been catastrophic for any civilization that existed on the continent at the time. A thriving culture enjoying temperate conditions would have found itself suddenly transported to polar latitudes, with temperatures plummeting and ice sheets rapidly expanding across the landscape. Those who could not escape would have been entombed along with their cities, their technology, and their entire way of life, preserved in ice like insects trapped in amber. This scenario provides a chilling alternative to Plato's description of Atlantis sinking beneath ocean waves. Instead of being swallowed by the sea, the great civilization would have been swallowed by ice, its magnificent structures and accumulated knowledge locked away beneath an ever-thickening frozen shroud. The survivors, if any existed, would have fled to other continents, carrying with them fragmented memories of their lost homeland that would eventually crystallize into the myths and legends found in cultures around the world. The preservation potential of Antarctic ice is extraordinary. Modern research has shown that organic materials can remain intact for millions of years when trapped in ice, with some samples retaining cellular structure and even DNA sequences. If an advanced civilization were indeed frozen beneath the Antarctic ice sheet, it would exist in an unprecedented state of conservation, with buildings, artifacts, and even organic remains potentially preserved in perfect detail. The Antarctic ice sheet reaches depths of nearly 3 miles in some locations, containing an estimated 7 million cubic miles of ice, some of which has remained frozen for over 1 million years. This represents the ultimate archaeological time capsule, a deep freeze that could preserve an ancient civilization in pristine condition, waiting for the day when technology and circumstances align to reveal its secrets. current ice-penetrating radar technology has already mapped Antarctica's hidden topography in remarkable detail, revealing mountain ranges, valleys, and other geological features beneath the ice. The Gamburtsev Mountains, discovered in 1958, stretch across an area the size of the Alps, yet remain completely hidden beneath the ice sheet. These ancient mountains, estimated to be around 1 billion years old, should have eroded away long ago but have been preserved by their icy shroud. If nature can preserve mountain ranges for such vast periods, it could certainly preserve the remains of human civilization for a mere 12,000 years. The search for evidence of this frozen Atlantis faces enormous challenges, but these obstacles may not be insurmountable forever. Antarctica is not as geologically stable as once believed, with accelerating ice loss in recent decades exposing features that have been hidden for millennia. Between 1979 and 2023, the Antarctic ice sheet lost nearly 5,000 billion tons of ice, contributing significantly to global sea level rise. While this ice loss poses serious environmental challenges, it also creates unprecedented opportunities for discovery. As we stand at this threshold between myth and potential reality, between ancient legends and modern science, we find ourselves confronting questions that challenge our understanding of human history itself. The convergence of Einstein's endorsement, ancient maps showing impossible knowledge, and growing evidence of Antarctica's temperate past creates a compelling case for taking the Antarctic Atlantis theory seriously. The implications of such a discovery would be staggering, potentially rewriting not just the story of human civilization, but our understanding of how advanced knowledge can be lost and preserved across the millennia. In the depths of Antarctic ice, beneath miles of frozen silence, there may lie answers to some of humanity's greatest mysteries, waiting patiently for the moment when technology and determination finally breach the barriers that have kept them hidden for thousands of years. But this is only the beginning of our journey into the frozen depths where legend and science converge. The story grows more compelling when we consider the sophisticated knowledge required to create the Piri Reis map and others like it. These aren't crude approximations or lucky guesses. The mathematical precision required to accurately project a spherical Earth onto a flat surface using the Mercator technique suggests access to advanced geographical and mathematical understanding that mainstream history insists didn't exist in the ancient world. But the Piri Reis map isn't alone in this mystery. Other ancient charts display similar anomalies, showing coastlines and geographical features with accuracy that should have been impossible without modern surveying techniques. The Orontius Phineus map of 1531 shows Antarctica as an ice-free continent with rivers, mountains, and coastal plains mapped in extraordinary detail. The Philippe Boitsch map of 1737 depicts Antarctica divided into two distinct landmasses connected by a narrow bridge of land, a geographical reality that wasn't confirmed until ice-penetrating radar revealed the true contours of the bedrock beneath the ice sheet in the 1950s. These maps collectively suggest that someone, at some point in history, possessed detailed knowledge of Antarctica's ice-free topography. The question becomes, who had this knowledge, and when did they acquire it? If we accept the conventional timeline of human history, no civilization should have possessed the technology and resources necessary to accurately map Antarctica during the brief periods when it might have been ice-free. This is where the Antarctic Atlantis theory becomes particularly intriguing. If an advanced civilization had indeed developed on Antarctica during one of its temperate periods, they would have possessed intimate knowledge of the continent's geography. As the climate began to shift and ice started to advance, the most prescient members of this civilization might have undertaken the monumental task of preserving their geographical knowledge, creating detailed maps that could guide future expeditions or serve as records for posterity. The survivors of such a civilization, fleeing to other continents as their homeland became uninhabitable, would have carried these maps with them. Over the centuries and millennia that followed, these precious documents would have been copied, recopied, and gradually corrupted through successive generations of cartographers who didn't fully understand the advanced techniques used in their creation. Yet even these degraded copies retained enough accuracy to astonish modern researchers when they were finally rediscovered. Charles Hapgood's investigation into these ancient maps led him to a startling conclusion. He proposed that an advanced maritime civilization had existed in the remote past, one capable of global navigation and accurate cartography. This civilization had mapped the entire world during a period when sea levels and continental positions were different from today. The maps that survive are fragments of this ancient geographical knowledge, preserved through chains of transmission that stretch back thousands of years. The implications of this theory extend far beyond Antarctica. If Hapgood was correct, then human civilization is far older and was once far more advanced than conventional history acknowledges. The rise and fall of this ancient civilization would represent a lost chapter in human development, a golden age of knowledge and exploration that was cut short by some catastrophic event and subsequently forgotten by history. Modern geological research has provided unexpected support for aspects of this theory. Studies of ancient climate patterns reveal that the Earth has experienced dramatic and rapid climate changes throughout its history, transitions that occurred far more quickly than the gradual shifts typically associated with long-term climate cycles. Ice core data from Greenland and Antarctica shows that regional temperatures can shift by more than 10 degrees Celsius within decades, and in some cases within years. These rapid climate transitions suggest that the Earth's climate system is capable of sudden reorganization, potentially triggered by factors such as changes in ocean circulation patterns, volcanic activity, or astronomical influences. If such a rapid climate shift occurred around 12,000 years ago, it could explain how a thriving Antarctic civilization might have found itself suddenly trapped in polar conditions, with little time to adapt or escape. The timing of this proposed catastrophe aligns not only with Plato's account of Atlantis, but also with a period of dramatic global change known as the Younger Dryas. This geological period, which lasted from approximately 12,900 to 11,700 years ago, saw a sudden return to Ice Age conditions across much of the northern hemisphere. Temperatures plummeted, ice sheets advanced, and many large mammal species went extinct. The cause of the Younger Dryas has been debated among scientists, with theories ranging from volcanic activity to meteorite impacts to changes in ocean circulation. Some researchers have proposed that the event was triggered by the sudden drainage of glacial lakes in North America, which disrupted the Atlantic Ocean circulation patterns and caused rapid climate change across the globe. Others suggest that a comet impact or a series of impacts might have triggered the cooling. Whatever the cause, the Younger Dryas represents clear evidence that the Earth's climate can change rapidly and dramatically. If Antarctica experienced a similar sudden shift from temperate to polar conditions, any civilization that existed there would have faced an unprecedented crisis. The speed of the change would have made adaptation impossible, and evacuation difficult, trapping much of the population and their achievements beneath rapidly accumulating ice. The preservation potential under such conditions would have been remarkable. Unlike other types of natural disasters that destroy and scatter evidence, rapid glaciation would have acted like a vast refrigerator, instantly freezing and preserving everything in place. Buildings would remain structurally intact. Organic materials would be preserved in perfect condition, and even delicate artifacts would survive undamaged beneath their protective blanket of ice. This scenario creates a fascinating paradox. The same catastrophic event that destroyed the civilization would also be responsible for its preservation. The ice that ended their world would become their eternal guardian, protecting their legacy from the erosion and decay that has claimed so many other ancient cultures. In a sense, the Antarctic ice sheet would function as the ultimate archaeological site, a frozen museum containing an entire civilization perfectly preserved at the moment of its demise. The technological capabilities required to create such a civilization become more plausible when we consider the sophisticated knowledge systems that existed in the ancient world. Recent archaeological discoveries have revealed that ancient cultures possessed mathematical, astronomical, and engineering knowledge that rivals modern capabilities in some areas. The precision of ancient megalithic construction, the accuracy of astronomical observations, and the sophistication of ancient calendars all suggest that human intellectual achievement reached remarkable heights in prehistory. If such advanced knowledge existed in other parts of the ancient world, there's no reason to assume that Antarctica was necessarily exempt from this flowering of human achievement. Indeed, the isolation of Antarctica might have been advantageous for the development of an advanced civilization, providing protection from the conflicts and invasions that plagued other regions while allowing for the peaceful development of sophisticated technologies and knowledge systems. The mathematical precision evident in ancient maps like the Piri Reis chart suggests familiarity with spherical trigonometry, coordinate systems, and projection techniques that we associate with modern cartography. Creating accurate maps of a spherical Earth requires understanding of complex mathematical relationships and sophisticated surveying techniques. The fact that such knowledge appears to have existed in antiquity challenges our assumptions about the linear progression of human technological development. Recent discoveries in neuroscience and psychology have also shed light on the remarkable capabilities of human memory in oral cultures. Before the advent of writing, humans developed extraordinary mnemonic techniques that allowed them to preserve vast amounts of detailed information across generations. Indigenous cultures around the world still maintain oral traditions that accurately preserve historical, geographical, and technical knowledge spanning thousands of years. If the survivors of an Antarctic civilization possessed such memory techniques, they could have preserved detailed knowledge of their homeland's geography, climate, and resources long after their physical separation from the continent. This knowledge, transmitted through oral traditions and eventually committed to maps and written records, could explain the mysterious accuracy of ancient cartography while providing a mechanism for the preservation of pre-catastrophe geographical knowledge. The question of what form such a civilization might have taken becomes increasingly intriguing as we consider the unique environmental conditions that Antarctica would have presented during its temperate periods. Unlike other regions where human development was constrained by competing populations and limited resources, An ice-free Antarctica would have offered vast expanses of unoccupied territory and abundant natural resources. The continent's position near the South Pole would have created unique seasonal patterns that might have encouraged the development of sophisticated astronomical observation and calendar systems. During the summer months, the sun would have remained visible for extended periods, while winter would have brought months of darkness illuminated only by stars and aurora. Such conditions would have been ideal for developing advanced understanding of celestial mechanics and seasonal cycles. The isolation of Antarctica would have also encouraged the development of maritime technologies and navigation techniques. Any civilization that developed there would have needed sophisticated boats and navigation skills to maintain contact with other continents or to explore the vast southern ocean. This maritime focus might explain the advanced geographical knowledge evident in ancient maps, as a seafaring Antarctic civilization would have been well positioned to explore and map the entire southern hemisphere. As we delve deeper into these possibilities, the boundaries between speculation and scientific inquiry begin to blur in fascinating ways. The evidence for an advanced ancient civilization in Antarctica remains circumstantial, built upon anomalies in ancient maps, gaps in conventional historical narratives, and the intriguing convergence of geological and climatological data. Yet the accumulation of these circumstantial pieces creates a picture that becomes increasingly difficult to dismiss. The greatest challenge facing researchers who wish to investigate these theories lies in the practical difficulties of Antarctic exploration. The continent remains one of the most hostile environments on Earth, where temperatures can drop below -80 degrees Fahrenheit and winds can exceed 200 miles per hour. The logistics of mounting large-scale archaeological expeditions in such conditions are daunting, requiring enormous resources and posing significant risks to researchers. Moreover, any potential archaeological sites lie beneath ice sheets that are miles thick in many areas. Even with modern ice-penetrating radar and drilling technology, accessing buried structures or artifacts would require massive engineering projects that dwarf anything previously attempted in archaeology. The cost and complexity of such endeavors make them unlikely prospects for conventional academic funding, relegating serious investigation of Antarctic archaeology to the realm of theoretical possibility rather than practical reality. Yet technology continues to advance, and climate change continues to alter the Antarctic landscape in ways that might eventually provide new opportunities for discovery. Satellite imagery has already revealed unusual geometric patterns beneath the ice that some researchers interpret as possible evidence of artificial structures. While mainstream science attributes these patterns to natural geological processes, the images remain tantalizingly suggestive to those who suspect that human artifacts might lie hidden beneath the frozen continent. The accelerating pace of ice loss in some regions of Antarctica has begun to expose areas that have been frozen for thousands of years, creating unprecedented opportunities for paleoclimatological research and potentially archaeological discovery. As more of Antarctica's hidden landscape becomes accessible to scientific investigation, we may finally obtain definitive answers to questions that have intrigued researchers for decades. The implications of discovering evidence of an advanced pre-Columbian civilization in Antarctica would extend far beyond archaeology and history. Such a discovery would fundamentally challenge our understanding of human development, technological progression, and the relationship between civilization and environment. It would force a complete reevaluation of ancient history and potentially provide insights into advanced technologies and knowledge systems that could benefit modern society. Perhaps most significantly, the discovery of a lost civilization preserved in ice would serve as a powerful reminder of the fragility of human achievement in the face of environmental change. The story of Antarctic Atlantis, if true, would be ultimately a cautionary tale about the vulnerability of even the most advanced civilizations to sudden shifts in climate and geography. As night deepens around us and the mystery of Antarctica continues to unfold in our imagination, we find ourselves standing at the intersection of science and wonder, where the impossible begins to seem merely improbable, and where the frozen continent at the bottom of the world holds secrets that could transform our understanding of human history itself. The mystery deepens when we consider the vast network of subglacial lakes that exist beneath Antarctica's frozen surface. These hidden bodies of water, completely isolated from the outside world for potentially millions of years, represent some of the most pristine environments on Earth. Lake Vostok, the largest of these subglacial lakes, lies buried beneath nearly 3 miles of ice and contains an estimated 1,300 cubic miles of liquid water. What makes these lakes particularly intriguing in the context of our frozen Atlantis theory is their potential as preservation chambers for ancient materials and structures. The water in these subglacial lakes remains liquid due to a combination of geothermal heat from below and the insulating properties of the thick ice above. Temperatures in these hidden lakes can reach several degrees above freezing, creating environments that could theoretically preserve organic materials and artificial structures in ways that solid ice cannot. If structures from an ancient civilization had become submerged in these lakes during the initial glaciation period, they might exist today in a state of preservation that exceeds even our most optimistic expectations. Recent microbiology research has revealed that these isolated lakes harbor complex ecosystems of bacteria and other microorganisms that have evolved in complete darkness and isolation for eons. The discovery of thriving life in such extreme conditions has revolutionized our understanding of where life can exist and how it can adapt to seemingly impossible environments. If simple life forms can survive and flourish in these conditions for millions of years, it raises profound questions about what else might be preserved in these hidden aquatic realms. The implications extend beyond mere preservation. Some researchers have theorized that if an advanced civilization had developed a sophisticated understanding of geothermal energy, they might have deliberately constructed settlements near areas of volcanic activity or geothermal vents. As the climate shifted and ice began to advance, these geothermally heated areas might have become refugia, where parts of the civilization could have survived longer than elsewhere on the continent. Such settlements, if they existed, might have gradually been flooded as geothermal activity melted overlying ice, creating the subglacial lakes we observe today. In this scenario, entire districts of an ancient city might lie perfectly preserved beneath the dark waters of lakes like Vostok, their buildings and artifacts maintained in a state of suspended animation by the unique conditions of these buried aquatic environments. The technological challenges of exploring these subglacial lakes are immense, but not insurmountable. Russian scientists spent decades drilling toward Lake Vostok, finally breaching its icy ceiling in 2012 after more than 20 years of painstaking work. However, Concerns about contaminating the pristine environment led to extremely cautious exploration protocols that limited what could be discovered during initial investigations. Future exploration of these hidden lakes will require sophisticated robotic submarines capable of operating in complete darkness under miles of ice. Such technology is already being developed for exploring the subsurface oceans of Jupiter's moon Europa and Saturn's moon Enceladus, where similar conditions exist. The techniques being pioneered for extraterrestrial exploration might ironically provide the key to unlocking the secrets of our own planet's most inaccessible realms. The geothermal activity that maintains these subglacial lakes also creates another intriguing possibility. Antarctica sits atop numerous volcanic systems, many of which remain active despite being buried beneath ice. The heat from these volcanic systems creates complex networks of caverns, steam vents, and warm zones that could theoretically have provided habitable spaces even during the harshest periods of glaciation. Indigenous cultures in other parts of the world have long traditions of using geothermal features for heating, cooking, and even creating temporary settlements during harsh weather. If an advanced Antarctic civilization had developed similar techniques on a larger scale, they might have created extensive underground complexes heated by geothermal energy. These subterranean cities could have served as refuges during the catastrophic climate shift, allowing portions of the population to survive the initial glaciation period. The volcanic activity beneath Antarctica has left traces that modern scientists are only beginning to understand. Airborne surveys using ice-penetrating radar and magnetic sensors have revealed dozens of previously unknown volcanic systems beneath the ice sheet. Some of these systems show signs of recent activity, with elevated temperatures and gas emissions that suggest ongoing geological processes. One of the most significant discoveries was made beneath the West Antarctic ice sheet, where researchers found evidence of a volcanic system larger than Yellowstone. This massive geothermal complex generates enough heat to melt significant amounts of ice from below, contributing to the instability of the overlying ice sheet. The existence of such extensive geothermal activity raises questions about how these systems might have affected the continent's habitability during previous warm periods. The relationship between volcanic activity and ice sheet stability is complex and dynamic. Periods of increased volcanic activity could have created temporary warm zones that supported life and possibly human habitation, while subsequent dormant periods might have allowed ice to advance and entomb any settlements that had developed. This cyclical pattern of warming and cooling could explain how evidence of ancient habitation might be preserved at various depths within the ice sheet, creating a stratigraphic record of human occupation spanning thousands of years. Recent advances in ice core analysis have revealed that Antarctica's climate history is far more complex and variable than previously understood. Deep ice cores from sites across the continent show evidence of rapid climate oscillations, volcanic ash layers, and even traces of atmospheric pollution that predate known sources by thousands of years. While most of this evidence can be explained by natural processes and long-distance transport of materials from other continents, some anomalies remain unexplained. Particularly intriguing are traces of metals and manufactured compounds found in ice cores that date to periods when no known human industrial activity existed anywhere on Earth. These chemical signatures are extremely faint and could potentially be explained by natural processes or contamination, but they represent the kind of evidence that would be expected if an advanced civilization had indeed existed on the continent in the distant past. The preservation of atmospheric chemistry in ice cores provides a remarkably detailed record of past environmental conditions. If an ancient civilization had developed metallurgy, manufacturing, or other industrial processes, traces of these activities should theoretically be detectable in ice cores that span the appropriate time periods. The fact that such traces are largely absent from the geological record could indicate either that no such civilization existed, or that their technologies were fundamentally different from our own industrial processes. This raises fascinating questions about the nature of any technology that an Antarctic civilization might have developed. Isolated from other human populations and facing unique environmental challenges, such a civilization might have evolved technological solutions that bear little resemblance to the development path followed by other human cultures. Instead of metal-based technologies that require high-temperature furnaces and produce distinctive atmospheric signatures, they might have developed biotechnology, crystalline energy systems, or other approaches that would leave minimal traces in the geological record. The unique environmental conditions of Antarctica would have encouraged certain types of technological development while discouraging others. The abundance of ice and snow might have led to sophisticated understanding of crystalline structures and phase transitions. The extreme seasonal variations in light and darkness would have necessitated advanced understanding of energy storage and management systems. The isolation from other continents would have required development of long-distance communication and navigation technologies. Some researchers have speculated that an Antarctic civilization might have developed acoustic technologies for long-distance communication, using the unique properties of ice and the polar atmosphere to transmit information across vast distances. Such technologies would leave no permanent artifacts, but could explain some of the mysterious acoustic phenomena that modern researchers occasionally detect in polar regions. The possibility of bio-integrated technologies is particularly intriguing, given what we now know about extremophile organisms that thrive in Antarctic conditions. An advanced civilization with sophisticated understanding of biology might have developed symbiotic relationships with these organisms, creating living technologies that could survive and function in extreme cold. Such biotechnologies would decompose naturally over time, leaving little trace for modern archaeologists to discover. As we consider these possibilities, we begin to appreciate the profound challenges facing any attempt to locate and identify evidence of ancient Antarctic civilization. The very factors that would have made such a civilization unique and adapted to polar conditions also make it nearly invisible to conventional archaeological methods. We are essentially searching for a needle in a haystack, where both the needle and the haystack are buried beneath miles of ice. Yet the search continues to fascinate researchers and capture the public imagination precisely because of these challenges. The idea that an entire advanced civilization could exist in perfect preservation beneath our feet, separated from discovery by nothing more than frozen water, represents the ultimate archaeological prize. It embodies humanity's enduring fascination with lost knowledge and hidden worlds, while simultaneously challenging our assumptions about the inevitability of human progress. The technological capabilities required to definitively explore Antarctica's subglacial environment are rapidly advancing. Autonomous underwater vehicles designed for polar conditions are becoming more sophisticated, while advances in remote sensing, allow researchers to peer deeper into the ice sheet than ever before. Machine learning algorithms are being developed to identify artificial structures in radar data, potentially allowing researchers to locate buried ruins without physically accessing them. Perhaps most significantly, climate change is altering Antarctica in ways that may eventually provide natural access to previously hidden areas. As ice sheets retreat and thin, areas that have been frozen for millennia are beginning to emerge into sunlight for the first time in thousands of years. While these changes pose serious environmental challenges, they also create unprecedented opportunities for discovery. The ethical implications of such discoveries would be enormous. If evidence of an advanced ancient civilization were found beneath Antarctic ice, questions would immediately arise about ownership, preservation, and study rights. The Antarctic Treaty currently prohibits territorial claims and military activities on the continent, but the discovery of significant archaeological sites might test these agreements in ways their original architects never anticipated. There would also be profound philosophical and spiritual implications to consider. Many indigenous cultures around the world maintain oral traditions about advanced civilizations that existed before historical records began. The discovery of a frozen Atlantis would validate these traditions while simultaneously raising questions about what other mythical accounts might contain historical truth. The story of Antarctic Atlantis thus represents more than just an alternative historical theory. It embodies humanity's relationship with mystery itself, our willingness to consider possibilities that challenge conventional wisdom, and our enduring hope that somewhere in the unexplored corners of our world, extraordinary discoveries await those brave enough to seek them. As we drift deeper into this frozen mystery, surrounded by the silence of polar night, we find ourselves contemplating not just what might lie beneath the ice, but what it would mean for our understanding of ourselves and our place in the long story of human civilization. The white continent at the bottom of the world keeps its secrets well, but perhaps not forever. The question of what happened to the survivors of such a catastrophic event leads us into one of the most intriguing aspects of the Antarctic Atlantis theory. If a civilization did indeed exist on the continent before its rapid transformation into a frozen wasteland, some of its people must have escaped to tell the tale. These refugees would have carried with them not just their lives, but fragments of their advanced knowledge, their cultural memories, and their understanding of the world that had been lost beneath the ice. Archaeological evidence from around the world suggests that something extraordinary occurred roughly 12,000 years ago, coinciding with the proposed timing of Antarctica's crustal displacement. Across multiple continents, we find evidence of sudden advances in human technology and culture that appear almost overnight in the archaeological record. The Neolithic Revolution, which saw the rapid development of agriculture, permanent settlements, and complex social structures, began during this exact period. In the ancient Near East, sites like Göbekli Tepe in Turkey demonstrate sophisticated architectural and astronomical knowledge that seems to have emerged fully formed, rather than evolving gradually from simpler beginnings. This massive stone circle complex, built around 9500 BCE, required organizational capabilities and technical skills that conventional archaeology struggles to explain, given the supposedly primitive nature of hunter-gatherer societies at that time. Similar anomalies appear in other parts of the world. In Peru, the site of Caral reveals evidence of a complex urban civilization dating to 3500 BCE, complete with pyramids, plazas, and sophisticated irrigation systems. The sudden appearance of such advanced urban planning suggests the influence of people who already possessed sophisticated knowledge of engineering and social organization. These scattered examples of precocious development might represent the influence of Antarctic refugees who brought advanced knowledge to various parts of the world after fleeing their frozen homeland. Small groups of survivors, arriving in different regions with fragments of their civilization's accumulated wisdom, could have served as catalysts for the rapid cultural development observed in the archaeological record. The linguistic evidence provides another tantalizing clue. Comparative linguistics has identified mysterious similarities between languages separated by vast distances and supposedly isolated populations. Proto-Indo-European, the hypothetical common ancestor of many European and Asian languages, contains words and concepts that suggest familiarity with advanced navigation, metallurgy, and astronomical observation. Some linguists have proposed that these shared elements might derive from contact with a highly mobile population that spread across the globe during prehistoric times. Could these linguistic traces represent the legacy of Antarctic survivors who established themselves in various parts of the world, contributing their vocabulary and concepts to local languages? The maritime terminology found in many ancient languages is particularly intriguing, suggesting contact with people who possessed advanced seafaring knowledge and techniques. The megalithic building traditions found on every inhabited continent present another puzzle that the Antarctic refugee theory might help explain. From Stonehenge in Britain to the Moai of Easter Island, from the pyramids of Egypt to the stone platforms of Nanmadol in Micronesia, ancient cultures around the world independently developed techniques for moving and precisely positioning massive stone blocks that challenge our understanding of prehistoric capabilities. These megalithic traditions share certain common features that suggest a shared source of knowledge. The precision of stone cutting, the astronomical alignments of many sites, and the sophisticated understanding of engineering principles required for their construction all point to contact with people who possessed advanced technical knowledge. If Antarctic refugees had developed expertise in working with ice and stone in their polar homeland, they would have been uniquely qualified to teach such techniques to the populations they encountered in their new homes. The astronomical knowledge embedded in these ancient monuments is particularly striking. Sites around the world demonstrate sophisticated understanding of celestial mechanics, precession cycles, and eclipse prediction that would have required centuries of careful observation and mathematical analysis to develop. The sudden appearance of such knowledge in multiple locations might be explained by contact with people who had already completed this lengthy process of astronomical observation during their previous existence on Antarctica. The seasonal extremes of polar regions would have made astronomical observation both necessary and rewarding for any Antarctic civilization. The months-long polar night would have provided ideal conditions for studying the stars, while the midnight sun of polar summer would have allowed for precise observation of solar movements. A civilization that had developed sophisticated astronomical knowledge under these unique conditions would have been well equipped to establish calendars and predict celestial events when they relocated to other parts of the world. The mathematical knowledge required for advanced astronomy also appears suddenly in the archaeological record around 12,000 years ago. The development of sophisticated numbering systems, geometric principles, and calculation methods seems to have occurred independently in multiple locations, suggesting either remarkable coincidence or contact with people who already possessed such knowledge. The preservation of advanced knowledge across generations presents its own set of challenges. In a world without writing, complex information had to be maintained through oral traditions, symbolic systems, and practical demonstrations. The survivors of an Antarctic civilization would have faced the enormous task of preserving as much of their knowledge as possible, while adapting to completely new environments and integrating with existing populations. This process of knowledge preservation and transmission might explain why advanced techniques appear sporadically in the archaeological record rather than as continuous traditions. Skills and information that required specific environmental conditions or materials to practice might have been lost when Antarctic refugees settled in regions that lacked these prerequisites. Other knowledge might have been deliberately concealed to prevent its misuse by populations that lacked the social structures to handle advanced technologies responsibly. The mystery schools and secret societies that emerged in many ancient civilizations might represent organized attempts to preserve fragments of Antarctic knowledge across generations. These exclusive organizations, with their emphasis on initiation, secrecy, and the gradual revelation of hidden wisdom, bear the hallmarks of systems designed to protect and transmit advanced knowledge in societies that might not be ready to receive it openly. The symbolism used by these mystery schools often includes references to lost golden ages, catastrophic floods, and the preservation of ancient wisdom. The Egyptian mysteries spoke of Zep Tepi the first time, when gods walked among men and knowledge was freely shared. The Greek mysteries referenced a golden age before the current Bronze and Iron Ages, when humanity possessed greater wisdom and lived in harmony with nature. These mythological frameworks might represent cultural memories of the Antarctic civilization, passed down through generations of initiates who understood that they were preserving the remnants of a lost world. The emphasis on astronomical knowledge, sacred geometry, and the cyclical nature of time found in these traditions aligns remarkably well with the kind of understanding that an Antarctic civilization would have developed. The flood myths found in cultures around the world take on new significance when viewed through this lens. Rather than representing separate cultural memories of local disasters, these stories might all derive from the shared trauma of the Antarctic refugees who witnessed the destruction of their homeland. The remarkable consistency of flood narratives across cultures that had no apparent contact suggests a common source for these stories. The details of these flood myths often include elements that make little sense in the context of ordinary flooding, but would be perfectly applicable to the kind of crustal displacement proposed by Hapgood. References to the earth shaking, the sky falling, and the entire world being transformed align with the catastrophic effects that would result from rapid movement of the Earth's crust. The survivors in these myths are often described as possessing special knowledge or divine favor that allowed them to escape destruction. Noah's advanced warning and detailed instructions for building the Ark, Utnapishtim's divine guidance in the Epic of Gilgamesh, and similar elements in other flood stories might represent cultural memories of the advanced knowledge that enabled some Antarctic residents to escape their continent's fate. The post-flood world described in these myths is invariably diminished compared to what came before. Humanity must begin again with reduced knowledge and capabilities, struggling to rebuild civilization from fragments of lost wisdom. This pattern matches perfectly with what we would expect if advanced Antarctic survivors had been forced to restart civilization in new environments with limited resources and no access to their former homeland's infrastructure. The dietary and agricultural knowledge that appears suddenly in the archaeological record also bears examination in this context. The domestication of plants and animals occurred remarkably quickly and simultaneously across multiple continents around 12,000 years ago, suggesting either extraordinary coincidence or the spread of agricultural knowledge by people who already possessed it. Some of the crops that were domesticated during this period seem poorly suited to their supposed regions of origin, leading botanists to propose complex theories about how these plants might have spread from their original habitats. If Antarctic refugees had brought seeds and agricultural knowledge from their temperate homeland, this might explain the sudden appearance of sophisticated farming techniques in regions where such knowledge had no apparent evolutionary precursor. The maritime technologies that enabled global exploration and trade also emerged during this period, with evidence of transoceanic contact appearing much earlier than conventional history suggests. The presence of cocaine and tobacco traces in Egyptian mummies. The genetic similarities between Pacific Island populations and South American peoples, and the distribution of certain plant species all point to extensive maritime contact during prehistoric times. An Antarctic civilization would necessarily have developed advanced maritime technologies to maintain contact with other continents and to explore the vast Southern Ocean. The survivors and skills necessary to establish trade networks and maintain contact of such a civilization would have possessed the knowledge across enormous distances, potentially archaeology struggles to accommodate. The metallurgical knowledge that appears in the archaeological record, explaining the evidence for prehistoric global contact that conventionaled during this period, also shows characteristics that might suggest Antarctic origins. The techniques for working with metals in extreme cold conditions, the understanding of alloys that remain workable at low temperatures, and the development of tools specifically designed for ice and snow work all appear during this time frame. Some of the most sophisticated examples of ancient metallurgy come from regions that seem unlikely sources for such advanced techniques. The precision bronze work found in ancient China, the complex alloys used in pre-Columbian America, and the question of what became advanced ironworking techniques that appeared suddenly in Africa all suggest contact with people who possessed mature metallurgical traditions of the Antarctic refugees in the long term, leads us into the realm of speculation. But the evidence suggests that their influence gradually dispersed and diluted over thousands of years. As these populations intermarried with local groups and adapted to new environments, their distinctive knowledge and cultural practices would have been absorbed into the broader stream of human development. However, certain bloodlines and traditions might have maintained stronger connections to their Antarctic heritage. The persistent legends of lost golden ages, the emphasis on astronomical knowledge in certain royal lineages, and the recurring themes of hidden wisdom in various cultural traditions might all represent the continuing influence of Antarctic genetic and cultural inheritance. The modern search for evidence of this lost civilization continues on multiple fronts. Genetic studies of human populations are revealing migration patterns and population mixtures that occurred during prehistoric times, potentially providing clues about the movement of Antarctic refugees. Archaeological investigations continue to push back the dates for various technological and cultural developments, gradually revealing a picture of human achievement that is far more complex and ancient than previously believed. Climate research is providing increasingly detailed pictures of past environmental conditions. confirming that rapid climate changes of the magnitude required by the Antarctic Atlantis theory have indeed occurred in Earth's history. Advances in ice-penetrating radar and remote sensing technology are gradually revealing more details about Antarctica's hidden topography, potentially identifying areas where evidence of past human habitation might be found. The convergence of these various lines of evidence creates a compelling case for seriously considering the possibility that human civilization is far older and more complex than conventional history acknowledges. While definitive proof of an Antarctic Atlantis remains elusive, the accumulating evidence suggests that this theory deserves more serious consideration than it has traditionally received from mainstream academia. As we contemplate the possibility that the blood of Antarctic survivors flows in human veins around the world today, and that fragments of their advanced knowledge still echo in our cultural traditions, we are forced to reconsider our understanding of human achievement and potential. The story of Atlantis beneath the ice becomes not just an alternative historical theory, but a reminder that human civilization has perhaps risen to great heights before, only to be humbled by the awesome power of natural forces. In the quiet darkness of polar night, as aurora dance across skies that once looked down upon thriving cities, we sense the weight of this lost legacy. Somewhere beneath miles of ice, the achievements of our ancestors wait in frozen silence, preserving secrets that could transform our understanding of who we are and where we came from. The white continent keeps its vigil, guardian of mysteries that span the ages, holding in its crystalline embrace the remnants of a golden age that vanished beneath the advancing ice, but left its mark upon the world in ways we are only beginning to understand. The technological achievements that such a civilization might have developed take on even more significance when we consider the unique materials and energy sources available in Antarctica's geothermal regions. Modern researchers have discovered that certain volcanic areas beneath the ice contain rare mineral deposits and crystalline formations that possess unusual electromagnetic properties. These natural phenomena, combined with the extreme conditions of polar environments, might have led to technological development paths completely unlike those followed by civilizations in more temperate regions. The piezoelectric properties of quartz crystals, which generate electrical charges when subjected to mechanical stress, would have been particularly relevant in an environment characterized by constant ice movement and seismic activity. An Antarctic civilization might have learned to harness these natural electrical phenomena, developing energy systems based on crystalline resonance rather than combustion or mechanical power. Such technologies would leave virtually no trace in the archaeological record, as they would rely on naturally occurring materials, arranged in patterns that might appear random to modern observers. The acoustic properties of ice and the unique atmospheric conditions at polar latitudes would have created opportunities for developing communication systems unlike anything known to other ancient cultures. Ice acts as an excellent conductor of sound waves, while the thin, dry polar atmosphere allows acoustic signals to travel enormous distances under the right conditions. A civilization that understood these properties might have developed continent-spanning communication networks, using nothing more than precisely positioned acoustic reflectors and carefully timed signals. These communication systems might explain some of the mysterious acoustic phenomena that modern Antarctic researchers occasionally detect. Low-frequency sounds that seem to originate from deep within the ice sheet, rhythmic patterns that don't match known geological processes, and acoustic anomalies that appear to be artificially generated could represent the remnants of ancient communication infrastructure still functioning after thousands of years beneath the ice. The mathematical understanding required to develop such sophisticated acoustic systems would have necessitated advances in wave theory, resonance calculations, and geometric acoustics that wouldn't be rediscovered by mainstream science until the modern era. The precision required to position acoustic elements across continental distances would have demanded surveying and navigation techniques of extraordinary accuracy. This raises intriguing questions about the astronomical knowledge that would have been necessary for such precise continental surveying. Any civilization attempting to establish accurate position measurements across Antarctica would have needed sophisticated understanding of stellar navigation, time measurement, and coordinate systems. The extreme seasonal variations in polar regions would have made astronomical observation both challenging and rewarding, potentially leading to calendar systems and celestial knowledge far in advance of other contemporary cultures. The preservation of such mathematical and astronomical knowledge presents its own mysteries. Complex numerical systems and geometric principles require continuous practice and teaching to maintain across generations. If Antarctic civilization was indeed destroyed rapidly by crustal displacement, how would such sophisticated knowledge have been preserved and transmitted to survivor populations? One possibility lies in the symbolic and artistic traditions that refugees might have carried with them. Archaeological evidence from around the world shows that mathematical and astronomical principles were often encoded in decorative patterns, architectural proportions, and ritual objects that could preserve complex information in forms that appeared purely aesthetic to casual observers. The geometric patterns found in ancient textiles, pottery, and architectural ornamentation might represent sophisticated mathematical concepts disguised as artistic expression. The spiral patterns that appear repeatedly in ancient art from cultures around the world might represent more than simple decorative motifs. Mathematical spirals based on the golden ratio and Fibonacci sequences appear in numerous prehistoric artifacts, suggesting knowledge of advanced mathematical relationships that wouldn't be formally described by European mathematicians until much later. If these patterns derive from Antarctic refugee traditions, they might represent fragments of a comprehensive mathematical system that was once used for practical calculations and engineering applications. The megalithic monuments found on every inhabited continent share proportional relationships that suggest common mathematical principles underlying their construction. The precise ratios found in the dimensions of pyramids, stone circles, and other ancient structures indicate understanding of geometric relationships that require sophisticated mathematical knowledge to calculate and implement. These shared proportions might represent standardized measurement systems or mathematical constants that were preserved and transmitted by survivor populations from a common source. The precision of these ancient constructions becomes even more remarkable when we consider the tools and techniques supposedly available to their builders. The accuracy achieved in cutting and positioning massive stone blocks exceeds what should have been possible with primitive tools, suggesting either advanced mechanical techniques or profound understanding of leverage, fulcrums, and force distribution that enabled small groups to accomplish seemingly impossible tasks. Some researchers have proposed that ancient builders might have used acoustic levitation techniques, employing precisely controlled sound waves to reduce the effective weight of heavy objects. While such techniques remain theoretical in modern science, there are documented cases of Tibetan monks using acoustic methods to move large stones, suggesting that sound-based manipulation of matter might be more feasible than conventional physics acknowledges. If an Antarctic civilization had developed mastery over acoustic phenomena, they might have discovered techniques for manipulating matter using sound waves that would have seemed magical to other cultures. Such knowledge, if preserved and transmitted by refugee populations, might explain the mysterious construction techniques used in megalithic monuments around the world. The biological knowledge that would have been necessary for survival in polar conditions might have led to medical and agricultural advances far beyond what other ancient cultures achieved. The extreme environments of Antarctica would have required sophisticated understanding of human physiology, nutrition, and adaptation mechanisms. Any civilization that thrived in such conditions would have necessarily developed medical knowledge and techniques for maintaining health in challenging environments. This medical knowledge might have included understanding of hypothermia prevention, altitude adaptation, and nutritional requirements for extreme conditions that wouldn't be formally studied by modern medicine until recent centuries. The pharmaceutical knowledge required to treat conditions specific to polar environments might have led to discovery of medicinal compounds and treatment methods that were subsequently lost when the civilization was destroyed. The agricultural techniques necessary for food production in polar conditions would have required innovative approaches to cultivation that might have included controlled environment growing, hydroponic systems, or symbiotic relationships with cold-adapted organisms. Such techniques, if preserved and adapted by refugee populations, might explain some of the mysterious agricultural advances that appear in the archaeological record around 12,000 years ago. The sudden appearance of sophisticated crop varieties that seem perfectly adapted to their new environments, despite having no apparent evolutionary predecessors in those regions, might be explained by the introduction of carefully developed plant varieties by people who already possessed advanced agricultural knowledge. The complex hybridization techniques required to develop such crops would have taken generations of careful selection and breeding, suggesting that this knowledge was already mature when it appeared in the archaeological record. The social and organizational structures that would have been necessary to maintain an advanced civilization in Antarctica's challenging environment might have led to innovations in governance, resource management, and social cooperation that were subsequently transmitted to other cultures by survivor populations. The need to coordinate activities across vast distances in extreme conditions would have required communication systems, decision-making processes, and resource allocation methods far more sophisticated than those typically associated with ancient societies. These organizational innovations might explain some of the mysterious aspects of early urban civilizations that appear suddenly in the archaeological record, with fully developed administrative systems, legal codes, and social hierarchies. The appearance of complex governmental structures without apparent evolutionary development might reflect the influence of people who already possessed mature understanding of large-scale social organization. The environmental knowledge that would have been essential for survival in Antarctica might have included understanding of climate patterns, weather prediction, and ecological relationships that enabled accurate forecasting of environmental changes. Such knowledge would have been invaluable to refugee populations settling in new environments, potentially explaining the rapid adaptation and environmental management techniques that appear in early agricultural societies. The astronomical knowledge required for navigation and timekeeping in polar regions would have necessitated sophisticated understanding of celestial mechanics, precession cycles, and the relationship between astronomical phenomena and terrestrial events. This knowledge, preserved and transmitted by survivor populations, might explain the mysterious astronomical alignments found in ancient monuments around the world. The precision of these alignments often exceeds what would have been necessary for basic calendar keeping or seasonal prediction, suggesting that their builders possessed theoretical understanding of astronomical principles that went far beyond practical requirements. The complex calculations required to predict precession cycles, eclipse patterns, and planetary movements indicate mathematical sophistication that challenges conventional assumptions about ancient capabilities. As we consider these possibilities, we begin to appreciate the profound implications of the Antarctic Atlantis theory for our understanding of human development and potential. If such a civilization did indeed exist and influence subsequent human development through its survivor populations, then many of the mysterious achievements of ancient cultures might represent not independent innovation but the preservation and adaptation of much older knowledge systems. The recurring themes of lost golden ages, hidden wisdom, and cyclical time found in cultures around the world might represent cultural memories of this Antarctic heritage, preserved through generations of oral tradition and symbolic representation. The emphasis on astronomical knowledge, mathematical precision, and harmonic relationships found in ancient traditions might all derive from a common source of advanced understanding that was nearly lost but not quite forgotten. The search for evidence of this lost civilization continues to evolve as new technologies and analytical methods become available. Advanced imaging techniques, chemical analysis methods, and genetic research tools are providing increasingly detailed pictures of prehistoric human activity and migration patterns. While definitive proof remains elusive, the accumulating evidence continues to support the possibility that human civilization is far more ancient and sophisticated than conventional history acknowledges. The implications extend beyond historical curiosity into practical considerations for our own civilization's future. If advanced human societies have indeed risen and fallen in the past due to environmental catastrophes, then understanding these cycles becomes crucial for preparing for similar challenges in our own time. The lessons of a frozen Atlantis might provide valuable insights into the relationship between technological advancement and environmental stability, warning us about the fragility of even the most sophisticated civilizations in the face of natural forces. Climate change research continues to reveal the dynamic nature of Earth's environmental systems and the speed with which dramatic changes can occur. The possibility that rapid crustal displacement or other catastrophic events could again transform our planet's geography and climate within human timescales reminds us that our current technological civilization, like all those that came before it, exists within a larger context of geological and astronomical forces that dwarf human control. The story of Antarctica's hidden secrets thus becomes not just a mystery from the past, but a mirror reflecting our own civilization's achievements and vulnerabilities. In the endless white expanse of the southern continent, beneath miles of ice that have accumulated over thousands of years, the remnants of human ambition and achievement may lie waiting, preserved in crystalline perfection, ready to teach us lessons about both the heights of human potential and the humbling power of forces beyond our command. As the polar wind carries its ancient secrets across the frozen landscape, and the aurora paint their ethereal patterns across skies that may once have looked down upon thriving cities, we sense the presence of this lost legacy. The ice keeps its vigil, guardian of memories that span millennia, holding in its frozen embrace the possibility that everything we think we know about human history is merely the latest chapter in a much longer and more extraordinary story. The white continent at the bottom of the world continues its patient watch, preserving beneath its surface the potential answers to questions we have barely begun to ask. In its silence lies the echo of vanished voices, in its emptiness the shadow of vanished dreams, and in its ice the promise that some secrets, no matter how deeply buried, eventually find their way back to the light. The preservation of organic materials in such extreme conditions defies our conventional understanding of decay and deterioration. In the permafrost regions of Siberia, researchers have discovered mammoth carcasses so perfectly preserved that their flesh remains edible after tens of thousands of years. Their blood flows liquid when thawed, their fur retains its original color, and their DNA remains intact enough for potential cloning experiments. If such preservation is possible in merely frozen ground, what might exist in the pristine conditions beneath Antarctica's ice sheet, where temperatures remain constant and contamination is impossible? The implications stretch beyond simple preservation into the realm of suspended animation. Recent discoveries have revealed microorganisms in Antarctic ice that remain viable after millions of years of dormancy, awakening to active life when exposed to appropriate conditions. These findings suggest that the boundary between life and death becomes blurred in the extreme preservation environment of polar ice, raising profound questions about what else might be waiting in similar states of suspended existence. If an advanced civilization had developed biotechnology or integrated living systems into their infrastructure, these organic components might exist today in states that blur the distinction between artifact and organism. Living buildings that could resume growth when conditions permit. Biological computers that preserve information in genetic codes, or symbiotic systems that merge technology with adapted life forms, could all theoretically survive in the unique preservation environment beneath Antarctic ice. The concept of information storage in biological systems has captured the attention of modern researchers, who have successfully encoded digital data in DNA sequences that can survive for thousands of years under appropriate conditions. An Antarctic civilization with advanced understanding of genetics and molecular biology might have developed information storage systems based on biological rather than mechanical principles, creating libraries of knowledge that could survive catastrophic environmental changes. Such biological information systems would be virtually undetectable to conventional archaeological methods, appearing as nothing more than unusual microbial communities or genetic anomalies in ice samples. The knowledge they contained would remain accessible only to researchers with sophisticated understanding of genetic codes and molecular biology, effectively creating a natural encryption system that protects advanced information from premature discovery. The symbiotic relationships between Antarctic organisms and their environment suggest possibilities for technological development that transcend our current understanding of the boundary between natural and artificial systems. Modern research has revealed complex ecosystems thriving in Antarctic ice caves, sustained by geothermal heat and chemical processes that create self-contained environmental bubbles within the frozen continent. These natural systems demonstrate principles of closed-loop resource cycling, energy management, and environmental control that exceed the sophistication of most human technologies. A civilization that learned to work with, rather than against, these natural systems might have developed technologies that were indistinguishable from evolved biological processes, creating infrastructure that appeared organic while serving technological functions. The acoustic properties of ice create possibilities for information transmission and storage that remain largely unexplored by modern science. Ice formations can act as natural wave guides, conducting acoustic signals across enormous distances with minimal loss. Complex patterns of density variation within ice could theoretically encode information in acoustic form, creating sound-based storage systems that would remain functional as long as the ice structure remained intact. The mathematical precision required to create such acoustic encoding systems would necessitate understanding of wave interference patterns, harmonic relationships, and crystalline acoustics that wouldn't be formally described until centuries later. The development of such systems would require not only advanced mathematical knowledge, but also sophisticated techniques for precisely controlling ice formation and crystalline structure. Recent discoveries of unusual acoustic phenomena in Antarctic ice have revealed sounds that don't match known geological or meteorological processes. These mysterious acoustic signatures, detected by sensitive monitoring equipment, exhibit patterns that suggest artificial origin but remain unexplained by conventional science. The possibility that these sounds represent the operation of ancient acoustic systems, still functioning after thousands of years, adds another layer to the mystery of what might lie beneath the ice. The energy systems that would have been necessary to sustain an advanced civilization in Antarctica's harsh environment would have required innovative approaches to power generation and distribution. The extreme seasonal variations in solar energy availability would have necessitated either highly efficient energy storage systems or alternative energy sources that could operate reliably in conditions of perpetual darkness. Geothermal energy represents the most obvious alternative. But harnessing such energy effectively would have required sophisticated understanding of thermodynamics, materials, science, and engineering principles. The development of geothermal power systems capable of supporting urban-scale energy demands would have necessitated drilling techniques, heat exchangers, and distribution networks that rival modern capabilities. The magnetic properties of certain minerals found in Antarctica's volcanic regions could have provided opportunities for developing electromagnetic energy systems that operated on principles different from those underlying modern electrical technology. The unique magnetic field characteristics at polar latitudes might have enabled energy generation or storage techniques that would be impossible to replicate at lower latitudes. These alternative energy systems would have left minimal traces in the geological record, particularly if they relied on naturally occurring electromagnetic phenomena rather than constructed infrastructure. The evidence for their existence might be limited to subtle magnetic anomalies or unusual mineral alignments that could easily be attributed to natural geological processes. The transportation systems required to move people and materials across Antarctica's vast distances would have faced challenges unlike those encountered by any other ancient civilization. The extreme cold, the seasonal darkness, and the constantly shifting ice would have demanded innovative solutions that bore little resemblance to conventional wheeled vehicles or even traditional maritime transportation. The development of efficient transportation systems for polar conditions might have led to technologies based on principles of friction reduction, magnetic levitation, or even controlled flight that were subsequently lost when the civilization was destroyed. Such transportation technologies would have required advanced understanding of physics, materials, science, and engineering that wouldn't be redeveloped until modern times. The infrastructure required to support such transportation systems might have included precisely surveyed routes, navigation beacons, and communication networks that spanned the continent. The remnants of such infrastructure, if they exist, might be detectable as geometric patterns in the bedrock beneath the ice, unusual mineral alignments, or electromagnetic anomalies that suggest artificial origin. The social implications of developing advanced technologies in Antarctica's challenging environment would have required unprecedented levels of cooperation, resource sharing, and long-term planning. The survival of any individual would have depended on the success of the entire community, creating social pressures that would have favored collaboration over competition and collective decision-making over individual autonomy. These social pressures might have led to innovations in governance, education, and resource management that were far ahead of their time. The need to maintain complex technological systems across generations would have required educational institutions and knowledge preservation methods that ensured critical information was never lost due to individual mortality or social disruption. The development of such sophisticated social systems would have required written or symbolic communication methods that could preserve complex technical and administrative information across time. The symbols or writing systems developed for these purposes might have been incorporated into the artistic and architectural elements that survivor populations brought to other continents, creating recurring symbolic patterns that appear in ancient cultures around the world. The medical knowledge required to maintain human health in Antarctica's extreme environment would have necessitated understanding of human physiology, nutrition, and adaptation that wouldn't be formally studied until modern times. The challenges of preventing hypothermia, managing altitude effects, and maintaining nutrition during months of darkness would have required sophisticated medical knowledge and pharmaceutical resources. The development of such medical expertise might have included discovery of medicinal compounds derived from Antarctic organisms, understanding of physiological adaptation mechanisms, and treatment techniques specifically designed for extreme environmental conditions. This knowledge, if preserved and transmitted by survivor populations, might explain some of the mysterious medical capabilities attributed to ancient cultures. The psychological challenges of maintaining mental health during the extreme seasonal variations and social isolation of Antarctic life would have required understanding of human psychology and social dynamics that preceded formal psychology by thousands of years. The development of techniques for maintaining morale, managing interpersonal conflicts, and preserving cultural identity under extreme stress would have been essential for long-term survival. These psychological insights might have led to innovations in education, entertainment, and social ritual that were designed to maintain community cohesion and individual well-being under challenging conditions. The cultural practices developed for these purposes might have been carried forward by survivor populations, influencing the ritual and ceremonial traditions found in ancient cultures around the world. The artistic and cultural achievements of such a civilization would have been shaped by the unique environmental conditions and social pressures of Antarctic life. The extreme seasonal variations in light and darkness would have created artistic sensibilities that emphasized dramatic contrasts, subtle gradations, and the interplay between illumination and shadow. The acoustic properties of ice and the unique atmospheric conditions would have influenced musical and poetic traditions that were specifically adapted to polar environments. The development of artistic forms that could be appreciated during months of darkness would have required innovative approaches to sculpture, decoration, and performance that might have influenced the artistic traditions of survivor populations. The mathematical principles underlying these artistic achievements would have been preserved in the proportions, patterns, and symbolic elements that appear in the cultural products of survivor populations. The geometric relationships found in ancient art and architecture around the world might represent fragments of a comprehensive aesthetic philosophy that was developed under the unique conditions of Antarctic civilization. As we contemplate these possibilities, we begin to sense the magnitude of what might have been lost when Antarctica was transformed from a temperate continent into a frozen wasteland. The knowledge, technologies, and cultural achievements that were developed over potentially thousands of years of Antarctic civilization would have represented a unique branch of human development that was cut short by catastrophic environmental change. The fragments of this lost knowledge that were preserved and transmitted by survivor populations might represent only a small fraction of the original civilization's achievements. The bulk of their accumulated wisdom, their technological infrastructure, and their cultural treasures would remain locked beneath the ice, waiting for the day when humanity develops the capability to safely access and study these remarkable remains. The search for evidence of this lost civilization continues to evolve as our technological capabilities advance and our understanding of Antarctic conditions improves. Each new discovery about the continent's hidden topography, its unique environmental conditions, and its complex geological history adds another piece to the puzzle of what might lie beneath the ice. The growing evidence for rapid climate changes in Earth's past, the discovery of sophisticated ancient technologies in other parts of the world, and the persistent legends of lost civilizations all support the possibility that the Antarctic Atlantis theory deserves serious scientific investigation. While definitive proof remains elusive, the accumulating circumstantial evidence creates a compelling case for keeping an open mind about what secrets might be preserved in the ice. The story of Antarctica's hidden past thus becomes a meditation on the nature of knowledge itself, the fragility of human achievement, and the ways in which the most extraordinary discoveries often emerge from the most unexpected places. In the vast silence of the polar continent, beneath ice that has accumulated grain by grain over thousands of years, the remnants of human ambition and creativity may be waiting to teach us lessons about both our past and our future. The white expanse stretches endlessly under star-filled skies that have watched civilizations rise and fall, their light traveling across distances that dwarf human comprehension. In that cosmic perspective, the possibility that advanced human societies have existed and vanished multiple times becomes not just plausible, but perhaps inevitable, part of the larger rhythms that govern the relationship between consciousness and cosmos. As the aurora paint their ancient patterns across the polar sky, as the ice shifts and settles with sounds that echo across empty valleys, we sense the presence of mysteries that transcend our current understanding. The continent keeps its vigil, patient guardian of secrets that may hold keys to questions we have not yet learned to ask, preserving in its crystalline depths the possibility that everything we believe about human history represents only the most recent chapter in a story far more extraordinary than we have dared to imagine. The magnetic anomalies that lie scattered across Antarctica's hidden bedrock tell their own story in patterns that resist easy explanation. Modern satellites, equipped with the most sensitive magnetometers, have detected geometric configurations beneath the ice that appear too regular, too purposeful to be products of random geological processes. These magnetic signatures form networks that span hundreds of miles, connecting points of unusual electromagnetic activity in ways that suggest deliberate design rather than natural occurrence. What makes these patterns particularly intriguing is their relationship to the continent's geothermal features. The magnetic anomalies often coincide with areas of elevated underground temperatures, creating a correspondence between electromagnetic and thermal activity that hints at integrated systems operating on a continental scale. If these patterns represent the remnants of ancient infrastructure, they would indicate technological capabilities that integrated multiple forms of energy in ways that modern science is only beginning to understand. The precision of these magnetic alignments becomes even more remarkable when considered alongside Antarctica's unique position at the convergence of global magnetic field lines. The continent sits at the center of electromagnetic phenomena that affect the entire planet, from the aurora australis that dance across polar skies to the magnetic storms that can disrupt satellite communications worldwide. A civilization that developed a sophisticated understanding of these electromagnetic relationships might have created technologies that operated in harmony with planetary magnetic systems. Recent advances in quantum physics have revealed that electromagnetic fields can be manipulated in ways that were previously thought impossible. The phenomenon of quantum entanglement allows particles to maintain instantaneous connections across vast distances, while electromagnetic resonance effects can amplify small inputs into large outputs through precisely tuned feedback systems. An ancient civilization with advanced understanding of these principles might have developed communication and energy systems that operated on quantum mechanical principles millennia before such concepts were formally described. The implications of such technological capabilities extend beyond mere speculation into the realm of practical possibility. Modern researchers have successfully demonstrated quantum communication systems, magnetic levitation devices, and electromagnetic energy transfer methods that would have seemed magical to previous generations. If an Antarctic civilization had discovered similar principles through empirical observation and experimentation, they might have developed technologies that appear supernatural to modern eyes while operating on perfectly natural physical laws. The crystalline structures found in Antarctica's volcanic regions possess properties that make them ideal candidates for quantum mechanical applications. Certain mineral formations exhibit piezoelectric effects, generating electrical charges when subjected to mechanical stress, while others display unusual optical properties that could theoretically be used for information storage or transmission. The combination of these natural quantum mechanical resources with advanced human understanding could have produced technologies that left minimal archaeological traces while achieving remarkable capabilities. The atmospheric conditions unique to polar regions create additional possibilities for advanced technological development. The extremely dry air, the minimal electromagnetic interference from human sources, and the unique properties of the polar magnetic field would have provided ideal conditions for developing sensitive detection and communication systems. The months of continuous darkness would have been perfect for astronomical observation, and the development of navigation systems based on stellar positioning with unprecedented accuracy. The psychological effects of living in such an environment would have profoundly shaped the consciousness and cognitive development of any civilization that thrived there. The extreme, seasonal variations in light and darkness would have created altered states of awareness that might have led to insights into the nature of consciousness itself. Modern research light cycles can induce heightened states of perception and expanded awareness that some describe as mystical or transcendent experiences. Tonight, we have journeyed through possibilities that stretch the boundaries of accepted history, following threads that weave between ancient maps and modern ice cores, between Einstein's endorsement and Plato's allegory. The idea that Atlantis might rest beneath Antarctic ice challenges everything we think we know about human civilization, yet the evidence continues to whisper from the frozen depths. Whether this lost world exists as crystallized fact or crystallized dream, its story reminds us that the greatest mysteries often lie not in distant stars, but in the unexplored corners of our own planet, waiting patiently beneath miles of ice for the moment when humanity is ready to listen to what the silence has preserved. Until we meet again, sweet dreams, fellow guardians of human wisdom.